All right, today, good morning, chemists. Today we're going to take it up to the next level. We were here on Wednesday. We're going to take it up a notch. We're going to go from mild to spicy. And then next week, we may go to atomic hot. But right now we're going to stick on spicy. So this is our reaction. This is the one we did on Wednesday, right? This is the fart ignition reaction, right? We talked about methane plus oxygen. We did this with both the can, with the lid popping off, and then a couple weeks ago you lit your hands on fire with the bubbles, right? So this is that reaction. I've already balanced it because I think at this point you should be able to set up and balance the reaction. If you can't, let me know or find a classmate, even better, find a classmate that can help you. But here's the question we're gonna answer. We're gonna say, I'm gonna say I have 10 grams of methane. How much carbon dioxide can I make? So to this point, the problems we worked on have only had moles. We've only worried about moles. So what we're introducing, what's new in this is that we're looking at grams now. Now why does that matter? Well, because if you remember, a mole of anything is 6.02 times 10 to the 23rd of that thing, right? So if I have 1 mole of sulfur and I have 1 mole of carbon, I have the same number of particles for each of those. However, if I have 1 gram of sulfur and I have 1 gram of carbon, those are not equal to each other. That is not the same number of particles, right? Because sulfur weighs more than carbon, so they're bigger. I have fewer sulfur particles if I have 1 gram than I would with carbon, right? So when we use mass, we have to do a conversion to moles. And let me show you how this works. So in this problem, we've got 10 grams of CH4 and we're trying to find CO2. So what I'm going to have you do is draw a reaction box. But this reaction box is going to have 2 levels to it, right? So I'm going to draw my reaction box under my reaction. I'm going to do line there, line there, line there. If I dance, I'm line dancing maybe. That's an old reference, but you guys look it up, you'll get it. You'll laugh later. Okay, so here is our reaction box. And where we had only 1 row before, we're going to actually add a second row. The top row is going to go G, right? The bottom row is going to be moles. So grams on top, moles on bottom. If you're not sure which one goes on top, it goes alphabetically, right? G is above M in the alphabet. So G on top, mole on the bottom. Now, we're going to fill this in. This is 10 grams. Right? We're trying to find how many grams of this, so we're trying to find that X. So how do I get this to this? Now, what we had done earlier in class, right, is you could look at this mole ratio and say, oh, it's 1 to 1. If this is 10, this should be 10, but remember that grams not equal. The amount is different for each thing. So what we have to do is we first have to convert 10 grams to moles. And so how do we do that? Well, anytime you're going from your reaction table from grams to moles, you're going to use the molar mass, and anytime you go down, you're dividing. So we're going to divide by the molar mass of CH4. So the molar mass of CH4, I could do a quick calculation and get 16. If you're not sure how I got the molar mass of 16, let me know. But now what I'm going to do is I'm going to do 10 divide by 16. So 10 divided by 16, and that comes out to 0.725. So I have 0.725 moles. And now what I can do is I can now look at the mole ratio and say, this is 1, this is 1, right? So this must be 0.725. Now, let's fill out the rest of the table, and then we'll find X, right? So this is 1 to 2, so if I'm here, I'm going to take this number, 0.725, and multiply it by the mole ratio of the box I'm in, 2 over the box I came from, 1, right? So that comes out to 1.5, 1.55, I think, yeah. And then this, now if we look here, these have the same mole ratio. So if this is 1.55, this will be 1.55. Now here's the final thing. How many grams of carbon dioxide do I have? Well, check this out. Before, when we went down the stairs, we divided. But what do we do when we're coming up? Whoa, 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 whoa. Well, if division is when you go down, to go up, everybody with me, say it, multiply, right? So we go this way, we're going to multiply by the molar mass. So what we have to do is find the molar mass of CO2. So if I look at this, this is 12. Oxygen is 16, so 16 times 2 is 32. So 12 plus 32 equals 44. So I'm going to take my 0.725, and I'm going to multiply that by 44 grams, and that's going to give me 38.7 grams. And now I know how much carbon dioxide I have, and that's it. You're done. If I wanted to find these, right, all I would need to do is find the molar mass of oxygen, multiply by 1.55, and find the molar mass of water and multiply by 1.55. So right here, this is an AP level problem that you guys can do, I think, no problem. It's going to take some practice, and we're going to do that today. But you got this, chemist. All right? Copper tomorrow.